Hello, algebra students, and welcome back to chapter 11.9. And this is day 1 of 11.9. This is a longer section for chapter 11 because it's all about equations. So we're going to be solving for unknowns, but what makes this chapter different than like chapter 2, for example, is there will be some radicals or some square root signs in the equation, and we need to figure out what happens when we have those radicals or when we have something squared in the equation, which we'll do later this week. So our essential question is, can I solve an equation when x is in the radicand? Meaning you might see something like that, where there's a square root and x is in, or x is the radicand. Or you might have something like 6x in the radicand. Or you might have something like 2x plus 1 in the radicand. So those are some examples. You wouldn't have to write those down. But that's what you're going to see. You're going to see equations with radicals and x's in the radicand. So firstly, we need to talk about some inverse operations. And what does that mean? So inverse operations, what is the inverse of multiplication? What undoes multiplication in an equation? What can I do to get rid of multiplication? Division. What is the inverse of addition? If I see an addition in the equation, I want to get rid of it. That is subtracting. And this is our new one today. This is what we're going to talk about. It's probably something you've seen before, but we're going to put it in our notes. If you see something with the square root and you want to get rid of the square root, just like if you want to get rid of multiplication by 3, if you want to get rid of the square root above the x, for example, you are going to square it. So if it's, if it's the square root of 2 squared, those roots and the squaring cross out, and we're going to see what that looks like. But this is important to have because this piece right here is new, or we haven't taken notes on it yet. So let's look at some examples and what this is going to look like. Example 1. We have an equation like this. What are we going to do? And I'm going to list 3 steps that work every single time when we have equations with roots. You need to get the square root by itself. And in this case, the square root, the symbol, is all by itself on the left-hand side, so I know that I'm good there. Then you're going to square, meaning put it to the power of 2, both sides to undo the square root. And what that means, because that they are inverses, I should use blue. I'll write over it there. So those are undoing each other. For example, if I just had the 4x, you would divide by 4 to get rid of it. If I want to undo or get rid of the squaring, you need to square it. But whatever you do to one side, you have to do to the other. So in this case, we had to get it all by itself, which it already was. Square both sides because that's going to undo the square root that we already had. So 4x is equal to, because those just crossed out, that's why the square root went away, but it doesn't cross out over here. In this case, I got rid of the square root, but 6 squared is 36. And then solve like normal. Or solve to get x by itself. If we're solving just to get x by itself, this problem right here is a 6th grade problem, a one-step equation. 4 multiplied by x, we're going to divide by 4, and x is equal to 9. So the only new thing is what we do when we see x in the radicand. Let's look at another example then. Example 2. The square root of 2x plus 3 is equal to 1. So our first step's up here. Get the radical by itself. Done. There's nothing else over here. It's just a radical with a whole bunch of stuff underneath it. Step 2, square both sides because that undoes the square root. So square root of 2x plus 3 squared is just 2x plus 3. It completely goes away. And then 1 squared is, well, that's 1 times 1, which is 1. And we're going to solve like normal. I'm going to do this really quick. So we're going to solve that equation for x. So sometimes the square root is all by itself, so this first step we're already done with, and then you just square it and solve like normal. And we're going to do one more example here. This example might look like that. So let's look at this example here. Our first step, get the square root by itself. Is that square root, ooh, I'm going to move this around, is that square root all by itself on one side? It is not. There's a +3 bothering us here, so we got to get rid of that 3. I'm left with my square root of x over here. 9 minus 3 is 6. Everything stays the same. My step 1 is done. I got the square root by itself. Step 2 is to square both sides so that the radical will cross out or will undo itself. And I'm left with x over here. But that squaring didn't get rid of anything, so we do have to use it. 6 squared is 36. And then it says solve like normal, but I'm done. I've solved it. X is by itself, and I'm all done there.